Good evening. In this session, we are going to discuss about the keyboard interfacing. So the entire unit is about interfacing with PIC microcontroller. So keyboard interfacing, LCD interfacing, analog to digital. In the first session itself, we have discussed that the interfacing types with PIC microcontroller or like LCD, keyboard, ADC, DAC, stepper motor, DC motor, etc. Okay, so now in this session we are going to discuss about how we are interfacing keyboard in microcontroller. So we all know very well about the keypad, right? We have a keypad in all our mobiles, then in our laptop system, everywhere in our day-to-day life we are using keypad, right? So keypad is a set of how you can you have seen the keypad, right? What are all the images, numbers and all it is available, right? In keypad we have like a set of buttons arranged in a block or pad, which usually consists of digits, then symbols, and usually a complete set of alphabetical letters, and it also contains number. Then it can also be called as a numeric keypad. Okay, so in that keypad there is a system of 4x4 matrix keypad. So how we are interfacing this keypad? So how to interface the 4x4 matrix keypad to two ports in microcontroller. So matrix means immediately we what we think, like what comes in your mind. Matrix means immediately what comes in your mind, that is your rows and columns, right? Matrix means simply it is a rows and column wise. So same system here, with rows and columns we are going to interface a keyboard with microcontroller, right? So this is the block diagram of interfacing a keyboard to microcontroller. This is the circuit diagram. You can see a row and column structure here, and also a port, that is your input D0 to D3, and you have in outputs you have 4 rows and 4 columns. Okay, this row and column just meets in a node, that is your point. Like it can be represented as A, B, C, D, or 1, 2, 3 for any alphabets or any numbers. Okay, so this is the row and call structure, and also we have 2 ports like port 1, port 2, then as usual our power supply, then VCC. Okay, so how this circuit diagram works, like when you detect a pressed key, the microcontroller grounds all rows by counting 0 to output latch, and then it reads the columns. So the data read from the columns is D3 to D0, that is D0, D1, D2, D3. If we assign it as 1 1 1 1 as input, if no key has been pressed, and the process continues until a key press is detected, right? For example, D3 to D0 means if we give, like instead of 1 1 1 1, if we give 1 1 0 1, this means that a key in the D1 column has been pressed. So the particular key will be enabled and all the remaining keys will be disabled. So after a key press is detected, the microcontroller will go through the process of identifying the key. So starting with the top row, the microcontroller grounds it by providing a low to row D0 only. Then it reads to the column. So we know very well 1 means high and 0 means low, right? While the data read is all ones, no key in that row is activated and the process is pulled down to the next row. It grounds the next row and reads the column and also bring it for any if we press any 0. This process continues until the row is identified, that is which part of the input is to be worked and which can be displayed. So here we have ports like port A, B, C, D, that is port A, port B, port C, port D, and all the pins are connected directly by the port pins. Okay, this is all about our keyboard interfacing. Like this keyboard interfacing, we can also interface LCD. In LCD we use 7 segment display, right? In LCD we use 7 segment display. Since it is a keyboard, we are using that 4x4 matrix, 4 rows and 4 column systems. Same, instead of this, for LCD interfacing we can use a 7 segment display, as well as we can also interface analog to digital converters and digital to analog converters. All or those types of interfacing. So in this unit we are completely going to discuss about the interfacing with peripherals with our microcontrollers. Thank you.